Hello. In a few short videos, I'm going to try to answer a question, which is, what do you really need to know about logarithm rules? There are a bunch of algebraic log rules that your teacher will be, or maybe has already started to teach you, and they are some of the most confusing looking and most error-prone areas of mathematics that young math students find themselves in. I'm going to try to give you some clarification how to approach this subject so that you're going to do really well with it. The first question that we should ask about a log rule, and I'm giving us an example of one here, is why is this strange rule true? So let me give you this one rule. This isn't all of the rules that you have to learn, but it is the one that usually is the first one, and it gives a great example of how to approach them. So this rule says that if you take the log base b of the product of two numbers, m times n, then it's equal to the log base b of one of those numbers plus the log base b of another one of those numbers. It's a very strange looking rule. You haven't seen anything like it before this in your math career. It doesn't fit nicely into ways of understanding that you've had before, and therefore it's going to be really easy to make mistakes with it and to mismemorize it too. So I'm going to have you think about why it's true in an effort to get you to really start to see this rule as, honestly, as a natural thing. Surprisingly, this thing actually says something you've known for a long time. Okay, so what is that thing that you've known for a long time? Well, to think about that, you need to remind yourself of what the definition is of a logarithm. And not the formal definition only, but also the informal one. The log base b of m. What that is that it is an exponent. Always remember this. Every log is an exponent. It's the particular exponent that you raise whatever that number b is to in order to get whatever that number m is. That's what it is. So, if we ever have that the log base b of m is equal to some number, and let's just name it x. Now you're seeing similar letters here as to this one. Don't worry too much about that right now. Just think about, suppose you had the log base b of m is equal to x. Then what this thing is an exponent, which means that x value is an exponent. It's the exponent you raise b to. So b to that exponent is going to get you m. This pair of definitions, the words and this statement, are crucial for you to remember. So if you haven't already done it, get on really starting to memorize this and to use it all the time. It's super useful. Okay, so to figure out why this rule is true, we're going to have to use this understanding. So I'd like for you on this thing to think about, instead of using the word let, I'm going to say that we name this number log base b to the m. Let's just, for the sake of giving it a symbol, let's actually name it x. So we name log base b of m equal to x. And similarly, let's name this log base b of n a different letter. I'm going to call it y. So these are just two new variables that I'm putting in. They're just names. But I want you to understand that from this definition, that means that we can rewrite this as b to the x equals m, and we can rewrite this as b to the y is equal to n. These look fancy, but they're just restatements of what, they're just restatements of what these things say. So hopefully you are starting to see the necessary equivalence of these two things and of these two. All right, so I'm on the road to trying to understand why this is true. And here's the actual news. This is actually just a restatement of an old exponent rule. It's just written in the form of logs. So I want you to consider an old exponent rule you've known for a long time. It's that if you ever take b to the x and you multiply it by b to the y, then that is always equal to b to the x plus y. Now this shouldn't look hard to you. You've probably studied this for a long time. Hopefully you started to really digest it. If you haven't, then work on that. But b to the x times b to the y is b to the x plus y. Now look at the similarities. There are some tantalizing, superficial similarities between this and this thing we're trying to understand. There is a product of numbers here. There's also sort of a product here. There is a sum of numbers in the exponent. There is a sum here. Actually turns out these are really staying the same thing. I'm going to show you right now why. So from this old exponent rule, I want you to think about, well, b to the x times b to the y. Now think about what we said over here. We said b to the x was this number m, and b to the y was the number n. So I'm going to write m times n here, because this is just what these are. M times n is b to the x times b to the y. But then I'd like you to acknowledge that this exponent rule works. This is equal to b to the power of x plus y. And now I want you to look at these two things. Just written in a slightly different form, all this is saying is that m times n is equal to b to the x plus y. But now take that equivalence and write it in its exponential form. Remember, when we have a number to a power equals a number, we can write it as a log. We're going to write this as a log. The log is the base b. Notice the exponent is x plus y, so that's what the log is, and it's of this number m times n. So all this statement says, mn equals b to the x plus y, can be captured in this statement. That means the log base b of mn is equal to x plus y. But now, just let's rewrite what x and y are. Remember, x was the log base b of m, so this is just the log base b of m. Y is just, so there's a plus, y is just the log base b of n. And look, we've just shown these two things are equal, which is exactly the rule we were trying to prove. That's it. I know that there's a lot of algebraic manipulation going on here, but really the essence of it is pretty much in the boxes here. I'll box this one too. All we're really saying is that this old rule you knew can be rewritten this way, which can be rewritten this way, and that is this rule. And there is the first rule of logs. Now, that answers my first question, which is why is the strange rule true? It is just a rewriting of an old rule that's not strange. It's the old exponent rule that's over this shoulder. But the second question I haven't quite answered. How do I avoid making mistakes with log rules? Here's the bad news. You have to practice. You have to practice and practice and practice. There are actually 3 log rules that go together. There's more than 3, but the 3 main ones that go together is the log base b of m over n is equal to the log base b of m minus the log base b of n. And the third rule is that the log base b of m to a power, which I'll call c, is equal to c times the log base b of n. This is really a rewrite of the rule b to the x times b to the y is equal to b to the x plus y. These are close cousins. Similarly, hopefully this makes sense, this is actually a close cousin of b to the x divided by b to the y is b to the x minus y. And you can see some of the similarities here. And rule number 3 is a very close cousin of the rule that says if you take b to the power of x to the power of, let's call it c, then that is the same as b to the x times c. That is actually a rewrite of that one. I'm not going to go through the formal proofs of those right now, and I don't think it's honestly in most of the students who are watching this video, in most of your best interests to look at those proofs. Instead, I want you to see where they're coming from and understand conceptually that they really are these old rules, but they aren't exactly the same. These are very nitpicky, And you have to have exactly these rules in place in order to use them. The mistake that most students make that leads to poor grades and poor understanding when using these rules, the mistake is they don't spend the time and the effort to really practice using these rules. That's my advice. Practice, practice, practice. There are two types of practice problems that you will probably see. There's more than two, but the main one, there are two types of practice. You're going to use, or you're going to see, one, condensing problems. I struggle to remember how to spell condensing. It is what it is. And two, you're going to see expanding problems. The condensing problems are going to be the ones that are, what they are, honestly, is they're just rules where you are taking logs like the ones on the right-hand side here, that are sums of logs or differences or products, and you're condensing them by turning them into single logs. What that means is these are just practice with moving from the right-hand side of these rules to the left-hand side. Expanding problems are the opposite. They're just problems that are built in order to make you take logs that are just single logs and use these rules to turn them into something that's been expanded out, if you can see that. These are some of the most artificial and kind of dumb problems in mathematics. Now, you might be surprised I just said that. They're artificial and dumb because they aren't problems that are really asking you to do anything very meaningful. They aren't application problems. They aren't about the real world. All they're doing is getting you prepared to see how to use logs in more important situations later on, namely in calculus. So here's my advice. Do the practice. Really learn to use these rules. I'll make at least one more video, a second part here, where I go through some of these practice problems. But be aware that when you make mistakes on these, it's a natural thing, and you just have to go back and correct them and keep working on it, and eventually the rules will start to be more fluid and easy to use. Good luck with it.